Hello, we are on 9.4, so we are nearing the end. This is the last section in chapter 9, and then we'll have probably one more video / 2 videos, shorter ones, to go over chapter 10, and then we'll be reviewing for the final. So you are nearing the end, so keep going. Okay, so 9.4 is testing the difference between proportions. So, is the proportion of men who regularly exercise less than the proportion of women who exercise regularly? Okay, so remember P hat is X over N. So, 10 out of 15 women. So that's your proportion. It's a decimal, not a percent. So our hypotheses are group 1 equals group 2, or that they're not equal. And again, we don't really care about what the proportion is. We just care about whether there's a difference. Okay, so this one also has a lot going on for the proportion test, but same idea where it's the sample statistic minus the population divided by the standard error. Except for now we have a P bar and Q bar. P bar is just the average of the two proportions. So P hat and P2, it's the average of those two. And then Q bar is just 1 minus P bar. Our assumptions for the z-test for two proportions. Samples must be random, independent, and n times p is greater than or equal to 5. So that's what you always see for proportions. Okay, so going to example 9.9, in a nursing home study mentioned in the chapter opening of statistics today, the researchers found that 12 out of 34 randomly selected small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate of less than 80%. At alpha equals 0.05, the tests the claim that there is no difference in the proportions of the small and large nursing homes with the resident vaccination rate of less than 80%. Okay, so our P1 is going to be small, and our P2 we're going to say is our large. So my first step is my hypotheses. So I'm saying that they are equal. So we're testing the claim that there is no difference. So this is our claim. And then it just says the alternative, it didn't say anything about it being greater or less than or anything like that. So it's just not equal to. So we have a two-tailed test. Okay, so our critical value alpha is 0.05. This is going to be a z-test. So you go to the z distribution, or you can go all the way to the bottom at the t distribution. So you're at 0.05 two-tail, so that's the middle column, 1.96. So our critical value is plus or minus 1.96. Okay, so here's our picture. We have 1.96 and negative 1.96. And we are testing that claim. So I'm going to go to the next page to do that. Step 3. So our test statistic, I'm going to write that down so we know what we need to find. So P1 hat minus P2 hat minus P1 minus P2 over square root of P bar, Q bar, 1 over N1 plus 1 over N2. Okay, so we need P1 bar, or P1 hat. So that was our small, so 12 out of 34 is 0.35. And P2 hat is 17 out of 24. So 0.71. And then N1 was 34, N2 was 24. then we need P bar. So that is x1 plus x2 over n1 plus n2, or just the average of our p hats. So we have 12 plus 17 over 34 plus 24. So we get 0.5. So then Q bar has to be 0.5. 1 minus 0.5. Okay, so now plugging those in, our P1 hat is 0.35, P2 hat 0.71, minus, remember we're hypothesizing that they are the same, so this is minus 0, divided by the square root of 0.5 times 0.5 times 1 over 34 plus 1 over 24. And that gives us negative 2.70. So step 3, our test value is negative 2.70. So that is going to be over here in the rejection region. So I'm going to reject. So reject H naught because negative 2.70 was less than negative 1.96. And our claim was in the null hypothesis, so we are rejecting the claim. So we say there is enough evidence to reject the claim. Okay. Next example, criminal arrest. So a study found that a random sample of 50 burglaries, 16% of the criminals were arrested. And in a random sample of 50 car thefts, 12% were arrested. At 0.10, can it be concluded that percentages of people who committed burglaries and were arrested was greater than the percentage of car thefts? So P1 we're going to call burglaries, and P2 we're going to do car thefts. Okay, so first step, P1 is equal to P2, and then we said greater, burglaries were greater than car thefts, and that's our claim. Step 2 is our critical value. This is again a z-test. Alpha is 0.10 and this is one tail. So if you go to the t-distribution, you can find this pretty easily. Just alpha, one tail, that'd be the first column. All the way to the bottom, remember we do 2 decimal places, so our z would be 1.28. And it's greater than, so we have a right tail. So, positive. Okay, step 3, P1 hat, it tells us is 16%. And P2 hat is 12%. Now, in order to find P bar, I can just average those two if I wanted to, or if you want to use the formula, you have to find x1 and x2. So to find x1, I just take 16% of 50, so I need to know what that is. That's 8. And this is 12% of 50, and that's 6. So if I want to find P bar, I take 8 plus 6 over 50 plus 50. And that gives me 14 out of 100, or 0.14. So that's just the average of 0.16 and 0.12. So then Q bar is 1 minus 0.14 to give us 0.86. Okay, so then we're ready for our Z. So we take 0.16 minus 0.12, P hat minus P hat, minus 0. P bar 0.14 times Q bar 0.86 times 1 over 50 plus 1 over 50. So our Z that we get is 0.58. So when I put that in my on my graph, 0.58 is not in the rejection region. So I am going to not reject. So step 4, do not reject H naught. 0.58 is less than 1.28. And so our claim was in the alternative hypothesis. There's not enough evidence to support the claim. All right, so our last thing we're going to do is the confidence interval. In the last 2 sections, we talked about it being able to also tell us whether to reject or not. The thing that's different about this is that instead of using P bar and Q bar, we're going to use P hat and Q hat. So the confidence interval is using a standard deviation based on estimated values of the population proportions, but the hypothesis test value uses the standard deviation based on the assumption that they're both equal. So it is possible to attain different conclusions. So we are usually going to use a z-test instead. So we aren't going to talk about whether 0 is in the interval or not. Okay, so the last one we're going to use example 9.9, which was the first one we did. So to refresh your memory, P hat was 0.35, P2 hat was 0.71, Q1 hat was 0.65, or is, because you take 1 minus 0.35, and Q2 hat, is 0.29. So our formula is P1 hat minus P2 hat plus or minus Z sub alpha over 2 P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Okay, and our Z sub alpha over 2 for 95% is 1.96. So we take 0.35 minus 0.71 plus or minus 1.96, and then we have 0.35 times 0.65 over N was 34. N1 was 34, N2 was 24. Plus 0.71, 0.29 over 24. So we get negative 0.36 plus or minus 0.242. So we get negative 0.602 less than P1 minus P2 less than negative 0.118. Okay, so that is our confidence interval. Let me know if you have any questions.